Thought I could leave you, 'cause I felt my heart numbing. It fit so deep it closed my eyes and I just took off running. And I felt sorry for the look on your face. Algebra 2, welcome once again to another tutorial exclusive. Alright, let's get it started. So, what we have on this screen here is a problem that before we could not solve. You see, this problem was impossible because once we try to solve this problem, well, what do we do to get rid of the square that we have right here? Well, of course, we take the square root. Right? Don't forget we always get a plus or minus in front, but I'm not going to worry about that right now. We're just going to get this right here, and we're going to get that x is equal to, plus or minus the square root of -4. Well, as you know, that's a problem because we can't take the square root of a negative number, right? So, I told you this was one of the biggest WTF moments with the function. And basically, to get around this, we decided to define something that's impossible possible. So we said I is equal to the square root of -1. And that's literally it. I is equal to the square root of -1. And that is our final answer. There's nothing else that we need to do, right? So I equals the square root of -1. Kaboom, karapish, we done. Okay. Now, what does that mean? Well, let's look at this example that we have over here, right? I'm not going to look at the plus or minus. I'm just going to look at let's just look at this, for example, here. Okay. So we have the square root of -4. Okay. Well, guess what? We can break this up as the square root of 4 times -1. Now, looking back at the reducing videos on the videos right beforehand, we saw this to be the square root of 4 times the square root of -1, right? Well, this is fantastic because we can solve this, right? What is the square root of 4? The square root of 4, well, that's just going to be 2 multiplied by, well, what's the square root of -1? Well, the square root of -1, we set that to be I. We're going to define it to be I, some imaginary number. So the square root of -1, I'll even draw it in a different color because it deserves it. It's just going to be 2i. So our answer is just 2i. Okay. So that's kind of an introduction to imaginary numbers. So what that means is, let's look at another example, right? Why not? Because we have the time. I'm feeling good. I'm feeling happy. So let's do it. Okay. So let's look at an example like 2 times the square root of -8. Well, we need to reduce this problem, and I also don't like the fact that, there's a 2 here. What do I do with both these things? Well, we just proceed, right? We want to reduce this down as much as possible. Because there's a negative in here, I want to pull that out. And we're going to be using this idea that we just saw here, that I equals the square root of -1. So we can write this as 2 times, okay, 8 times -1, and then we're going to get 2 times the square root of 8 times the square root of -1, right? I'm just using that conjecture that I talked about in the previous video. All right, so what did we say the square root of -1 was? Well, the square root of -1 is just I. So down below here, we can rewrite this as 2 times the square root of 8 multiplied by I. Okay. Now all I'm going to do is, this is a multiplication, right? For example, 2 times 3 is equal to 6. 3 times 2 is equal to 6, right? Doesn't matter if the 2 is in front or if the 2 is on the back over here, right? 2 times 3 is 6. 3 times 2 is 6. So this is the same principle. This is literally just going to be 2i. I'm just rearranging it. Square root of 8. Okay. Now, it looks like we did a lot of work already. But we need to reduce the square root of 8. The square root of 8 is not completely simplified. So let's do it, right? Well, we just proceed like before. And we're going to get 2i square root. Well, we divide this by the first perfect square, 4. Well, that's 2. So we get 4 times 2. And then we can break this up as 2i square root of 4 times the square root of 2 using the conjecture. Well, what is the square root of 4? You're right. That's 2. So we're going to get 2i times 2 times the square root of 2. All right. Now, you can see here in this problem that, again, it's a multiplication problem. So all I'm going to do is I'm going to multiply the 2 and the 2 first. What's 2 times 2? Well, that's 4. So I'm going to get 4i square root of 2. And this is my final answer here. So when I'm dealing with radicals that have a negative in there, I just pull it out. Right now I showed all my steps, so let me show you an example problem and that I would be totally fine with. Let's say we have 3 square root of negative, let me see here, I don't know, I'm trying to think of something. Let's say 45, right? Because I did use this example beforehand, right? So we start that off. Let me just go ahead and open up my handy dandy graphing calculator. Okay, so again, we see this negative in here, right? And if you want to, if you get really good at this, you can just say, all right, well, I know that there's a negative in here. This is going to be 3 square root of 45 times negative 1. And I know, just like before, that because of the negative 1 in here, right, this is just going to become 3 square root of 45 times I, right? I'm pulling out that negative 1, the square root of negative 1 is just I, so I could pull it out. Now I go to find, well, before I go to do anything, I'm just going to rewrite it as 3i square root of 45. And now we just want to find perfect squares of 45, right? Now you probably already know this because of the other video, but like before, we start with all the perfect squares. So I start with 4, that doesn't work. So then I just keep going, I go to 9, and would you look at that, 9 works. So I can rewrite this as 3i square root of 9 times 5. Oops, let me rewrite that more nicely. Okay. And then last but not least, well, like I said, if you want to, you can just think about it, and you could do it this way, right? You don't have to show your work all the way, but the video above hopefully should help explain that, right? The square root of 9 is 3. So you're going to get 3 times 3i. I'm just pulling out this right here. The square root of 9 is 3, and that gives me the 3 here. And then last but not least, we're going to get the square root of 5 because I can't compute that, right? 5 is already simplified, and so we're going to get 9i square root of 5 because the 3 and the 3 multiply to give you 9. So this is one video just showing you some quick, fast way to go about doing it. Again, if you need to practice, then just do the step-by-step, right? So for example, do 3i square root of 9 times square root of 5, right? And then we're going to get 3i times 3 square root of 5. And then we just rearrange it like I showed you before. We just put the 3's together, and that's when we would actually get over here, 3 times 3, and then just we put the I on the end there, right? And ultimately it doesn't matter, right? Some of you are maybe in the habit of doing just keeping the I out here like that, and that's fine. It's up to you to just proceed however you want to, as long as you get your final simplified answer. All right, so hopefully this gives you an idea on how to reduce problems that have the square root of a negative number, because you're right, we can't get a real solution, but we can get an imaginary solution, and that's how we're going to work with these radicals, reducing these. Hopefully this helps you. Have a fantastic Friday.